Top 30 MEP Fresher Interview Questions and Answers. Starting a career in mechanical, electrical, and plumbing MEP engineering can be both exciting and challenging, especially for fresh graduates entering the professional world. Employers look for candidates who understand core concepts, practical applications, and teamwork in real project environments. This guide presents the top 30 MEP Fresher Interview Questions with detailed 70-word answers to help you boost confidence, improve technical understanding, and prepare effectively for upcoming interviews. 1. What is MEP and why is it important in building construction? MEP stands for Mechanical, Electrical, and Plumbing Engineering, which forms the backbone of building functionality. These systems ensure proper ventilation, heating, cooling, electrical power distribution, lighting, water supply, and waste management. MEP coordination reduces conflicts between systems, improves efficiency, and enhances safety. A building may have perfect architecture, but without MEP systems, it cannot operate. Therefore, MEP is essential for creating safe, livable, and energy-efficient structures. 2. What does HVAC mean, and what is its role in MEP systems? HVAC stands for heating, ventilation, and air conditioning. It regulates indoor temperature, humidity, and air quality, ensuring comfort and safety for occupants. In MEP systems, HVAC also includes equipment such as chillers, AHUs, FCUs, ducts, and ventilation fans. Proper HVAC design ensures energy efficiency, reduces operational costs, and meets building codes. It plays a vital role in maintaining indoor environments in commercial, industrial, and residential structures. 3. What is the difference between an AHU and FCU? An air handling unit AHU is a larger system that conditions and circulates air throughout an entire building. It usually connects to ducting and works with chillers. A fan coil unit FCU is a smaller, localized unit used for individual rooms or zones. It has simpler components and works with chilled water or refrigerant. AHUs handle fresh air intake, while FCUs mainly provide cooling or heating for smaller spaces. 4. What is a chiller and where is it used? A chiller is a large machine used to remove heat from water, producing chilled water for cooling systems. It is commonly used in commercial and industrial buildings where large-scale air conditioning is needed. Chillers work in conjunction with AHUs and FCUs. They enhance energy efficiency, maintain temperature stability, and support cooling for data centers, malls, hospitals, and high-rise buildings. Chillers are essential when split units are insufficient. 5. What are electrical load calculations, and why are they important? Electrical load calculations determine the total power required for a building's equipment, lighting, HVAC systems, and appliances. They ensure that electrical panels, transformers, cables, breakers, and generators are properly sized. Accurate load calculations prevent overloading, power failures, and equipment damage. They also ensure safety, energy efficiency, and compliance with standards. For MEP projects, load calculations form the foundation for designing reliable and cost-effective electrical systems. 6. What is a single-line diagram, SLD, in electrical engineering? A single-line diagram, SLD, is a simplified electrical drawing showing how power flows from the source to the loads. It uses symbols in single lines to represent circuits, transformers, breakers, cables, and panels. SLDs help engineers visualize system components, understand electrical distribution, and troubleshoot faults. They are crucial for design, installation, and maintenance. SLDs also ensure coordination among electricians, contractors, and consultants throughout a project. 7. What is a circuit breaker and what is its purpose? A circuit breaker is a protective device that automatically stops electrical flow during overloads, short circuits, or abnormal conditions. It prevents fires, equipment damage, and electrical hazards. Circuit breakers can be MCBs, MCCBs, or ACBs depending on capacity. In MEP systems, they ensure safe operation of lighting, HVAC equipment, and mechanical systems. Breakers are essential components in electrical panels and are carefully selected through load analysis. 8. What is the purpose of earthing/grounding in electrical systems? Earthing or grounding provides a safe path for electrical faults to flow into the ground, protecting people and equipment from electric shocks. It stabilizes voltage levels, prevents fires, and enhances system reliability. Proper grounding is required for all electrical panels, metallic enclosures, and sensitive equipment. In MEP systems, grounding ensures compliance with safety standards and supports smooth electrical performance in commercial, industrial, and residential buildings. 9. What is the importance of plumbing in MEP systems? Plumbing ensures safe water supply, efficient drainage, wastewater disposal, and fire protection through sprinkler systems. It includes pipes, valves, pumps, tanks, and sanitary fixtures. Proper plumbing design prevents leaks, water contamination, and system failures. It also supports sustainable water management. Plumbing plays a major role in occupant comfort and building hygiene. In MEP coordination, plumbing systems must integrate seamlessly with mechanical and electrical layouts. 10. What is a plumbing fixture? Give examples. A plumbing fixture is any device connected to a plumbing system that interacts with water. Examples include sinks, toilets, showers, bathtubs, faucets, and urinals. These fixtures allow users to access clean water or dispose of wastewater. Proper selection and installation ensure durability, hygiene, and water efficiency. Fixtures must comply with building codes and flow rate standards to support sustainability and meet occupant needs in residential or commercial buildings. 11. What is a pump and where is it used in MEP systems? A pump is a mechanical device used to transport fluids by increasing pressure and flow. In MEP systems, pumps are essential for water supply, chilled water circulation, firefighting systems, drainage, and wastewater management. Common types include centrifugal, booster, and submersible pumps. Correct pump selection ensures efficiency, reduces energy consumption, and maintains system reliability. Pumps are integral to HVAC operations, plumbing networks, and fire protection systems across various buildings. 12. What is the purpose of a firefighting system in buildings? A firefighting system ensures fire safety and protection for occupants and property. It includes sprinklers, hydrants, pumps, extinguishers, and alarms. These systems detect, control, and extinguish fires before they spread. MEP engineers design fire systems according to NFPA or local codes to ensure efficiency and reliability. Proper installation, maintenance, and testing keep buildings safe, reduce risks, and ensure emergency preparedness during fire incidents. 13. What is a sprinkler system and how does it work? A sprinkler system is an automatic fire suppression system that releases water through sprinkler heads when heat from a fire activates them. Each head operates independently using a heat-sensitive bulb. When triggered, water sprays over the affected area to control or extinguish flames. Sprinklers are part of fire protection design in commercial and residential buildings, reducing fire damage and enhancing occupant safety. 14. What is the difference between voltage and current? Voltage is the electrical pressure that pushes electrons through a conductor, while current is the flow of electrons. Voltage is measured in volts, whereas current is measured in amperes. Both are essential for electrical systems. Understanding their relationship helps in designing safe circuits, selecting appropriate cables, and ensuring the proper functioning of equipment. In MEP engineering, voltage and current principles guide electrical load calculations and system safety. 15. What is lux and why is lighting design important? Lux is the measurement of light intensity on a surface. Lighting design ensures adequate illumination for comfort, safety, and productivity. It helps determine the number of lights, fixture types, and placement in different spaces. Proper lighting design prevents glare, reduces energy consumption, and complies with standards. In MEP, lighting calculations optimize efficiency and enhance interior and exterior environments in homes, offices, hospitals, and commercial buildings. 16. What are ducts and why are they important in HVAC systems? Ducts are pathways that distribute conditioned air throughout a building. They carry supply, return, and fresh air to maintain desired indoor conditions. Proper duct design ensures efficient air distribution, minimizes energy losses, and enhances occupant comfort. Ducts must be correctly sized and insulated to prevent air leakage. In HVAC systems, ducts form a vital link between AHUs, FCUs, and occupied spaces, supporting ventilation and air quality. 17. What is BMS and how does it support MEP systems? A building management system, BMS, is an automated control system that monitors and controls mechanical, electrical, and plumbing systems. It manages HVAC performance, lighting, power usage, fire alarms, and security systems. BMS improves energy efficiency, reduces operating costs, and ensures smooth building operations. For MEP engineers, BMS helps track faults, optimize system performance, and maintain safe, comfortable environments. It is crucial in modern smart buildings. 18. What is static pressure in HVAC systems? Static pressure is a resistance to airflow within ducts and HVAC components. It affects how air moves through the system. High static pressure can strain fans, reduce airflow, and increase energy consumption. Proper duct design, filtering, and equipment sizing maintain optimal static pressure. Understanding static pressure helps engineers ensure efficient air distribution, reduce noise, and maintain comfort levels in buildings. 19. What is the significance of pipe sizing in plumbing design? Pipe sizing ensures adequate water flow and pressure throughout a plumbing system. Undersized pipes cause pressure drops and poor flow, while oversized pipes increase costs and reduce efficiency. Correct pipe sizing supports balanced distribution for drinking water, drainage, waste disposal, and fire systems. Engineers use calculations and standards to determine sizes. Proper sizing prevents leaks, improves efficiency, and ensures long-term reliability in all plumbing installations. 20. What is a VAV system in HVAC? A variable air volume (VAV) system controls airflow based on space temperature requirements. It supplies varying amounts of conditioned air to maintain comfort and reduce energy consumption. VAV boxes regulate airflow for each zone, improving system efficiency. Compared to constant air volume systems, VAV saves energy, reduces operational costs, and enhances comfort. It is commonly used in offices, malls, hospitals, and commercial buildings. 21. What are electrical panels and why are they important? Electrical panels house circuit breakers, bus bars, and protected devices that distribute power safely throughout a building. They control electrical supply to lighting, HVAC systems, and equipment. Proper panel design ensures safety, prevents overloads, and simplifies maintenance. Panels must follow electrical standards and be easily accessible. They are critical for regulating power flow and ensuring safe, stable electrical operations in any MEP project. 22. What is a UPS and where is it used? A UPS, uninterruptible power supply, provides temporary backup power during outages. It protects sensitive equipment such as computers, servers, medical devices, and security systems. UPS systems prevent data loss, enhance safety, and ensure continuous operation until backup generators start. In MEP engineering, UPS selection is based on load capacity, runtime, and battery type. UPS units play an essential role in buildings requiring uninterrupted power. 23. What is the difference between primary and secondary HVAC systems? Primary HVAC systems produce chilled or hot water using chillers and boilers. Secondary systems distribute this water using AHUs and FCUs to different zones. The primary loop handles energy generation, while the secondary loop manages air distribution. This separation increases control, reduces energy cost, and improves comfort. Understanding both systems helps engineers design efficient HVAC layouts for commercial and industrial buildings. 24. What is commissioning in MEP projects? Commissioning is the process of testing, verifying, and ensuring that MEP systems operate as designed. It includes inspections, performance tests, balancing, adjustments, and documentation. Commissioning ensures functionality, safety, and efficiency. It resolves installation issues before building handover. Proper commissioning enhances reliability and reduces future maintenance. For MEP engineers, commissioning is a crucial step in ensuring project quality and client satisfaction. 25. What is insulation and why is it used in MEP? Insulation reduces heat loss or gain in pipes, ducts, and equipment. It improves energy efficiency, prevents condensation, reduces noise, and enhances system performance. In HVAC, insulation helps maintain desired temperatures. In plumbing, it prevents freezing and heat loss. Electrical insulation protects against shock and short circuits. Proper insulation also prevents moisture damage and supports sustainability. It is a key component in efficient MEP design and installation. 26. What is the purpose of a drainage system? A drainage system removes wastewater and rainwater safely from buildings. It includes pipes, traps, vents, and manholes. Proper drainage design prevents blockages, foul odors, and backflow. It ensures hygiene, safety, and environmental compliance. Drainage systems must follow slopes, pipe sizes, and venting standards. MEP engineers design drainage to ensure smooth flow, avoid flooding, and support efficient building operations. 27. What is a transformer and how does it work? A transformer transfers electrical power between circuits using electromagnetic induction. It steps voltage up or down based on building requirements. Transformers ensure safe, efficient power distribution to panels and equipment. They reduce energy losses and stabilize voltage levels. In MEP systems, transformers are essential for high-rise buildings, industries, and commercial spaces. Proper transformer selection improves performance, safety, and compliance with electrical standards. 28. What is DB, MDB, and SMDB in electrical distribution? DB, distribution board, supplies power to smaller circuits like lighting and sockets. SMDB, submain distribution board, connects the MDB to DBs. MDB, main distribution board, receives power from transformers or generators and distributes it to SMDBs. This hierarchy ensures organized, safe power distribution. Understanding these boards helps engineers design structured electrical networks for commercial, residential, and industrial projects. 29. What is a VRF/VRV HVAC system? VRF, variable refrigerant flow, or VRV, variable refrigerant volume. Systems use refrigerant as the cooling/heating medium and allow multiple indoor units to connect to one outdoor unit. They provide zone-wise control, energy efficiency, and flexible installation. These systems adjust refrigerant flow based on demand, reducing energy consumption. VRF/VRV systems are popular in offices, hotels, hospitals, and residential complexes due to their reliability and comfort. 30. What skills should an MEP fresher have? An MEP fresher should understand basic HVAC, electrical, and plumbing concepts, along with drafting skills using AutoCAD or Revit. Problem-solving, teamwork, analytical thinking, and communication are essential. Knowledge of codes, safety practices, and project documentation helps in professional tasks. Freshers should be eager to learn, adapt quickly, and apply theoretical knowledge to real situations. These skills help them grow and contribute effectively in MEP projects. Preparing for MEP interviews as a fresher becomes much easier when you understand the basic systems, components, and engineering principles involved in real projects. These top 30 questions and detailed answers help you build confidence, improve technical knowledge, and present yourself as a strong entry-level candidate. Consistent practice will strengthen your problem-solving abilities and make you interview-ready. Use this guide to excel in your upcoming MEP engineering interviews.